So, in yesterday's session, we were looking at how to create calculation views. I will continue the session today. Just I will give a 5 minutes recap. So yesterday we looked at the definition of the calculation view. So click on the calculation view. So calculation views are used to create your own data foundation. Using other views or database tables. A calculation view can join several fact tables. Calculation views can be created as a graphical view or as a scripted view. So based on this definition, yesterday we have seen the data source, the data sources that the calculation view can have. First one is attribute views. Analytic view. Third one is a calculation view. The fourth one is tables. The operators that the calculation view can have. The first one is projection. Second one, union. Third one, join. Fourth one is an aggregation. The data categories inside the calculation view, we have three data categories. One is cube. The second one, cube with star join. And third one is the dimension modeling. So in the yesterday's session, we have seen how to create a cube. So when creating a cube, we can access all these information views. So all these three information views, including tables. So when we have created yesterday one example, we have taken one actual and plan, and we have done union between both actual and plan. We tried to combine actual data with plan data. And in the union, we created union with constant values, where union with constant values will differentiate rows coming from actual table and plan table. So let us go to the yesterday's model. Let's expand system, expand content. Let us go to ECC July 19 package. Let's expand the package, expand subpackage, master data, and here you find the calculation views. Expand the calculation view. So here, yesterday we created this calculation view. Double click. So first we have taken projection. Projection is for selection of columns. Union combining the results. We have created indicator to differentiate the rows coming from, it's used to differentiate the rows coming from actual as well as plan. And finally, the semantics. So also, one of the attendees asked how to create a calculated key figure. So we don't have to combine. So in this case, what we have done is we have added VV010, VV01, 0001, and then we have created a calculated column at the aggregation. At the aggregation, we have created a calculated column. In the semantics, we hide the original columns and we hide these original columns. And then we're trying to show the difference between VV010 and VV01, 0001. So that is what we have done yesterday. In today's exercise, what we will see is how to create cube with star joins. Now, what is the difference between an analytic view and cube with a star join? Analytic views executes on OLAP engine and they can have only a single fact table. Cube with star joins can have several fact tables and they execute on a calculation engine. When we create an analytic views, the master data that is provided to an analytic view is an attribute view. Attribute views are the dimensions in the analytic view. But for cube with star join, the dimensions are the calculation views of type dimension. So, when we create a dimension models, the data category as a dimension means it is for master data. So what information views are based on the data category dimension? One is the attribute view. The second one is the calculation view. Attribute views, the data categories as a dimension, can be used as the dimensions in the analytic view. Data categories of type dimensions in the calculation view can be used to provide master data in cube with star join. Now, why should cube with star join use calculation views of type dimension? Because the limitation is when we are using cube with star join, attribute views and analytic views cannot be used as data sources. We cannot use attribute views or analytic views as data sources when we create cube with star join. Now, what is the reason behind it is cube with star joins execute on a special kind of engine which is known as SQL engine. When we execute these views on SQL engine doesn't support to execute attribute views or analytic views. Now, if attribute views are not supported to be executed on SQL engine, then how could we get master data to the cube with star join? The way to get master data to cube with star join is a calculation view of type dimension. So that is why for master data modeling, we have two views. One is an attribute view, the other one is calculation views of type dimension. So first I will proceed to create calculation views of type dimension. Both produce the same result. Attribute views produce the same result. Calculation views of type dimension produce the same result. But due to the limitation of cube with star join, because we cannot use attribute views as the dimensions, we need to create the same functionality that is available in the attribute views in the calculation views of type dimension. So let us start to create calculation views of type dimension. Let us go to HANA Studio. Let us go back to HANA Studio. Let us right click on the calculation. Let us right click on the package, click new, click on the calculation view. Let's provide the name CV underscore company code. A data category. Let us select dimension. If you set the data category as a dimension, the default node is the projection. So what is the default node when we take cube? It is aggregation. When we take default node as a dimension, when we take the data category as a dimension, the default node is the projection. Click finish. Let's click finish. So once we click finish, so here we see semantics. The second node we see projection. So click on join. Let's click on join. Click on the join. So at the join, let us click on the plus icon, which is add objects. So let us create the same functionality of company code. So how we created in the attribute view, let me cancel this. So in the attribute view, if you remember, we have created a company code. So with the same functionality, how we have created a company code in the attribute view. Now please see here, when we click on semantics, what is the data category over here? Now this is the attribute view that we are seeing here. When you double click here, the data category is the dimension. Now even this is the symbol for attribute view, and this is for calculation view. Now let's click on the calculation view. Click on the semantics. Now what data category we see here? This is also a dimension. So dimension models can be created, calculation views as well as attribute views. A dimension data category can be used for attribute views as well as for calculation views. So we've clicked join and we have clicked on the join over here. So once we click, now in the attribute view, what we have done at the data foundation, we have joined T001 with TVKO. You see here T001 with TVKO. So let's go back to calculation view. So in the join, now what is a join? A join is a query based on a condition. Let's click on the plus icon and let us add both tables. First one is T001 from HANA user. First table is T001 from HANA user. Let us select T001 from HANA user. Click OK. Let us select the second table. Click on the plus icon and give the second table TVKO and select from HANA user. TVKO from HANA user. Click OK. So here we have T001 and TVKO. Let us join both of these tables the same way as we have done in the attribute views. Join BUKRS with BUKRS. The join type is an inner join. Company code ID, company code text, company code 1000. The text is IDSAG. So what do we require? What company codes? What sales organization? So under each company code, how many sales organizations? So these are known as simple joins. In a simple join, we cannot have more than two tables. So let me try to insert one more table. Let us try. Please see, this is disable. And attribute views have complex joins. Means you can insert multiple tables in the data foundation. But here, for one join, we can only have two tables. If you want to have few more tables to be joined, then click on the join again. Click on the work area. Click on the work area. Join 1 to join 2. So this is the output from join 1. Also let us select currency. So here we have BUKRS, BUText, VKORG. We don't have currency, so let us go back to join 1 and let us select WAERS. Click on the join 2. So for the join 2, now join 1 is the input. Let us click on the plus icon at the join 2. And find for the table TVKOT. Select the table from HANA user. Click OK. So here you have join 1 and this is the TVKOT table. So the relation between join 1 and TVKOT, link VKORG with VKORG. The columns that we require for the output. So what columns we require for the output? We require company code ID, company code text, sales organization ID. The text is over here, which is vtext. So select vtext. Now what is the relation between both these tables? It's simple. If it is an attribute table and this one is a text table, obviously it will be a text join. So select the join type, select, click on here and select text join. The language column, let us select as SPRAS, SPRAS, which is the language key. So let us also select currency. So in here you have, if you want to arrange these columns, you can arrange by clicking move up, company code text, sales organization text, and currency. Now for currency we do not have text. So let us click on the join again and let's click on the free space. The join 3. Let us join 2 to join 3. So this is the output of join 2. So what do we require? We require currency text. So currency text, click on the plus icon. The currency text is available at TCURT. TCURT from HANA user. TCURT from HANA user. Click OK. Now we are at the join 3. Let us join 2 to TCURT. So what is the relation? WAERS with WAERS. Again, this would be a text join because we're joining to a text table. Join type select as text join and language column as SPRAS. So what do we require? We require L text, which is long text. So this is the currency ID, EUR, and this gives the text euros. So here, let us select company code text, sales organization text, currency and currency text. Now once we have got all the fields, all the required fields for the output, let us link join 3 to the projection. Now finally, let us select projection. Now this is the output that we require. So the final output we derived by joining these 3 tables. Now here you can indicate, now this symbol indicates for inner join, this is for text join, and this is also for text join, and this is the projection. If you want to select all the columns at once, right click on join 3, add all to output. Finally click semantics. These are the columns that are available for output. If you want to arrange this, if you want to arrange all the nodes, click on the below icon, which is auto layout. Now let us provide at least one key attribute. The company code ID, obviously the company code subject area, obviously company code will be the key. This is the key attribute. And let us do the same thing, descriptive mapping. So WAERS, the descriptive mapping is L text. So this is the description for this ID. For company code, the description is BU text. This is the ID and this is the text. For sales organization, this is the text, which is vtext. Now let us hide the text columns. Let us hide the text columns. L text, BU text, and then vtext. Once we hide the text columns, finally let us click on save and validate and click on save and activate. If you want to check whether the view is active or not, let us click on the show log, job log, activation completed successfully. In order to check for data preview, let's check for data preview. Let's scroll down, right click on the company code, click data preview, click raw data. Now let us filter on one company code, click add filters, click BUKRS, Let us click show list of values and select 1000 company code. Select, click on this arrow button. Selected value is 1000 and click OK. Now you see here company code, sales organization and currency. Now let us see this calculation view is executed on what engine. What engine is processing this data? Double click on the calculation view. So this is the data model we just created. Click on the free space. Just click on the free space. So first click on the node. First click on the node and then click on the free space. Then here you would see the properties. So let us see the properties of the calculation view. Let us see the properties. The name, CV underscore company code. Label, column engine is the calculation engine. So what engine is being utilized? Calculation engine is being utilized. So the second engine that you have here is execute in. So a calculation view can be processed in two engines. One is a calculation engine, the other one is the SQL engine. So coming back to the diagram, cube with start joins are especially optimized to be executed on SQL engines. Calculation views of type cubes are optimized to be executed on calculation engines. But what is the limitation when we execute cube with start joins? We cannot use attribute views. So the functionality of the attribute view, we have created a calculation view of type dimension, and we are going to use these dimensions in the cube with start join. Now let us compare the dimension models, attribute view and calculation view. Does both of them produce the same result? But this execute on a join engine and this one execute on the SQL engine. So let us go back to HANA Studio and we'll change the execute in to SQL engine. Let's select SQL engine. Let us click validate and save and activate. Right click on the calculation view, data preview. Let me show you again. Click on raw data, add filter, BUKRS, select 1000 company code, click on show list of values, select 1000 company code and click OK. So here you see, now this is the output for the calculation view. Let us also right click on the attribute view, click open, click on the free space. So what engine does the attribute view execute on? It's a join engine. It cannot be executed in the SQL engine. It can only be executed on the join engine. The second thing is click on data preview. Here also we can see data preview. Let us click on this icon and click raw data and click add filters and click BUKRS and click show list of values and select 1000, selected value and click OK. So here it is basically showing, for 1000 it is showing all the texts. Probably there is a change. So let me go back to company code. I think there are a few changes in the joins. Let me check once. Thanks. There is some change over here. Please see there is an inner join. That's why we're getting the values repeatedly. Let me change to text join again. This one is the old view that we created last week. Let me validate and activate this view. And let us re-preview data. Again, let us preview the data. Right click on company code, data preview. Click raw data. Add filters. BUKRS. Show list of values. Select 1000. Selected value. Click OK. So, does the output of attribute view and the calculation view of type dimension both are same? Please see. So this one, if you want to check whether this is an attribute view or not, here you can click on show log. Double click on the generated SQL. Here we can see sys underscore BIC AT. AT is an attribute view. So this is the result from the attribute view. Close and close. And the other one you see here, click show log. Double click just to check. This is CV. This is calculation view. Close and close. So both the results are same. 7 rows, and here also it's 7 rows. So now why did I create again the same view which produced the same result? The reason is simple. Attribute views cannot be used in the cube with start join. So I need to create calculation views of type dimension. Now this is when you have more than one fact table you want to design in the cube with start join. So when you have a single fact table start schema, when you have more than one fact table snowflake schema. So we can create snowflake schemas in cube with start joins. So quickly let us create the other, because in order to complete this scenario we need to create the other attribute views as calculation views of type dimensions. So let me right click on the calculation view, new, and let us give the name CV underscore customer, label, view type is calculation, data category dimension, click finish. Let us quickly create. So we have other two views, customer and material. So click on the join, click on the join, click on the plus icon, KUNNR, sorry, KNA1, from KNA1 from HANA user, click OK. Click on the plus icon, T00 5T. So similar, I'll do it for customer as well. Similarly, I will do it for customer. Land 1 to land 1. Customer name 1. Regio. So same, whatever we have done in the attribute view, we are recreating the same scenario, but with using calculation views of type dimension. Same functionality. Customer, we require country text. So let us click join again. Link join 1 to join 2. The join 2. Select join 2. This is the output. Press icon. T005 view. From HANA user. Click OK. Let us join Regio with BLand and land 1 with land 1. Same functionality. Let us select all the columns for the output. So what do we require from this table? BJDI. And link join 2 to projection. Click auto layout. Click projection. Right click on the join 2. Click add all to output. Click on semantics. Key attribute. So once you know one, the rest is same. ID with description. Land 1 with landx. KUNNR with name 1. And hide the text columns. Click validate, save and activate. Same procedure be created for customer. Right click on the customer, data preview. Now again let us do the same check. Click raw data. Somewhere we have not taken text join. Please see here we have taken this as inner join. So this should be a text join. Once this is done, validate, save and activate. View got activated. Right click, data preview, raw data. So let us click add filter, KUNNR 001 or 2, any value. OK. So this is the output from the attribute view. Sorry, this is the output from the calculation view. Right click on customer, data preview, raw data, add filter, KUNNR. Let us filter on 2. Select, click OK. Please see 002 wet DE Germany 08 Baden. And the calculation view also produce the same result. 002 wet DE Germany 08 Baden. Both are same. And let me create the other final one, which is the material. So right click on the calculation view again, new, same procedure, AT underscore material. Technical name and description. Give the label, data category dimension, and sorry, it is CV, not AT. CV underscore material, data category dimension, click finish. So click on the join, the same. For material master, table is Mara. From HANA user, click OK. So we require only one join over here because we only have two tables, Mara and MAKT. Select MAKT. From HANA user, click OK. Join MATNR with MATNR. Material ID and material text, MAKTX. Join type, same procedure. Language column. Same as attribute views. Join one to projection. Require material group, MATKL. Same to same how we have done in the attribute views. I'm doing it the same procedure. Click semantics. Click on the projection, right click. Add all to output. Click semantics. Key attribute. So descriptive mapping is not mandatory, but if you provide descriptive mapping, it will be easy for business. It will be easy for business user to see key as well as text. If he is wishing to see key and text, if you specify this, it will be easy for him to see key and text functionality. We have given key attribute and done descriptive mapping. Validate and save and activate. Once this is done, once this is completed, Finally, let us check for material. Right click on CV material, data preview, raw data. So 001, sorry, 23 test material. Let us right click on attribute views, data preview, 23 test material. Now attribute view 23 test material. So we have completed one part of the exercise. So before we create a start join, it is necessary that we need to create calculation views of type dimension. So that's we have created today. So in tomorrow's session, what we will do is we'll create a calculation view of type start join by taking these three as dimensions. So in order to create a start join, right click, new. Let us give a name CV underscore actual underscore plan underscore COPA underscore data underscore start join. So in creating a start join, data category cube, we need to check start join and click finish. So once you click finish, now we see what is the node here. The node is the start join. So in the start join, is it possible to select an attribute view and drag and drop inside this? Please see, it doesn't allow. So that is the limitation over here. So if it doesn't allow, how will start join get master data? It doesn't allow attribute views, so we drag and drop CV underscore customer. So select CV customer, drag and drop. Please see, it does allow. So in tomorrow's session, we continue with creation of calculation views of type start joins, and then later we will see different engines that are available in HANA and how each engine performs and best practices to utilize these different engines. If you have any questions for today's session, until creation of calculation views of type dimension, tomorrow we'll start with calculation views of type start joins. The start joins we will discuss tomorrow. Today we only done with the dimensions. Is it mandatory to give descriptions? It's not mandatory, but if you give, it is better. Because as we discussed, users will have less effort to bring all the columns to the output. You don't find any schemas in the catalog. So if you don't find any schemas in the catalog, what you have to do is just right click on the catalog and just refresh. Just try to do refresh, then you can see schemas. If you still don't find, just please take a snapshot, screenshot. Please send an email. We'll see why it is not shown. But 100% it should show. Just right click and refresh, it should show the schemas. The cube type CV can process multiple fact tables. Yes, it can process multiple fact tables. Please explain when we need calculation view. Calculation views A simple explanation of a calculation view is you want to create your own data foundation when you want to take several fact tables. What's the need of a start join? Start join has better performance than creating calculation views of type cubes. So that is, it has better performance when you compare with cubes. That is why we require start joins. And why calculation views is because simple reason is several fact tables. Because our questions most of the time will require measures from multiple fact tables. And analytic views doesn't allow because it has a limitation. It can only allow one fact table. So in order to answer those kind of questions, we require calculation views of type cubes, star joins, and always calculation views of type star joins are better optimized in execution. And star joins are only introduced in SP8 Service Pack 08. So before that we do not have star joins. So during that time we were only using calculation views of type cubes. Because customers complain about the performance, SAP has come up with the new kind of join, which is star join. So union with constant value is used when you want to differentiate what rows are coming from what projection. So you can create a constant value assigning the data that we are getting from actual. All the rows will be displayed as actual. And the rows that are coming from plan, all the rows will be displayed as plan. So does SQL engine optimized for query runtimes? Yes, exactly. SQL engine is optimized for query runtimes. Any other questions, please? So can we copy an attribute view to a calculated view? We cannot do that. We can only copy the same views to same views, like attribute view to an attribute view and calculation to calculation. But it cannot convert from attribute view to a calculation view. That is a manual procedure. Attribute views. Now next question, what is the difference between an attribute view and a calculation view? Calculation views are mainly optimized to execute on CE engine, whereas attribute views are optimized to execute on join engine. That is the primary difference. And attribute views of dimensions, they can only handle master data, but calculation views can handle both master as well as transaction. It depends on the data category that we select. So what data category we have, based on that we can do the data modeling. So some questions, I'm skipping some questions because those questions we'll see in the later session. So there's no limitation on how many dimensions we can connect to fact table, unless and until it depends on the scenario. I mean, there's no limitation as such. You can have a number of dimensions. So in the simple join, we can only have two tables. We cannot have more than two tables. So that is the limitation from SAP. So that is for best performance. Always we need to follow best practices, but it may take little while to do the same process, but that is the process we have to follow. So it's the same procedure we have to create. In HANA implementation, do we need maximum time to create views? Yes, exactly. Most of the time will be data modeling, creating of views. Most of our time will be creating of information views. Is there any concept of dimension ID? If you're asking with comparison to BW, no. Yes. So here, for one fact table, analytic views are created. Yes, exactly. If you have one fact table, then we create analytic views. Next question, is there any SID tables in HANA? Yes, you will have SID tables in HANA when you have BW powered by HANA. Next, if we need a query on multiple fact tables, then do we require calculation view? Yes, we require calculation view if we have multiple fact tables. The query requires information views are actual data containers in HANA. They don't contain data but only access data in runtime, and the data is accessed by the underlying engines. The processing of data is done by the underlying engines. Data is always in tables, but only views access data at runtime by using these powerful engines that they process data for specific views. For attribute views, join. Analytic OLAP, Calculation CE, Calculation Views of type star joins use SQL Engine. There is no limitation on number of tables we can use unless and until your query does not have bad performance. Calculation start join can be run on with a calculation engine. Start joins can be run on calculation engine, but always better to run on SQL engine.